Hello everyone, thank you for joining me today. And in this presentation, I'm going to explain the weather service activity. And in this activity, I will cover some topic like what problem we are facing, and along with the problem, I will provide the best solution that we created to overcome this situation. Also, I will explain the pseudocode and briefly explain the flowchart, and at the end of this video I'll explain why you should have to consider our solution and implement it in your system. So the workshop number 2, other service activity. The problem is that we are facing is there is no software or other tool that tells us which and how many trucks needed in winter season to clear the snow in entire city. And as of now we have only a chart which is too tedious to read and calculate the trucks of sand and salt. And if we have some types of algorithms or a software, and along with the help of the software we can easily figure out the trucks to be needed to the site. And so to overcome the situation we have created an algorithm with step-by-step process which will automatically shows the number of trucks and types of trucks like plow, sand and salt. For this solution, user has to input only three types of values at the beginning. First one, the type of weather like snow, ice and mist. Second one is the temperature range, and third one is the accumulation per hour. Based on the above data, our solution will show the output. Now I will explain the pseudocode, how our program exactly works. In this pseudocode, it is easily understandable. Now I will explain the pseudocode. We divide our program into 8 steps which will gather the information, initial value from the user and generate the output. If user enters the snow and the accumulation per hour is less than or equal to 2.5 centimeter, and if the temperature is less than minus 10 degrees centigrade, then the software will produce the output of one light sand truck needed. And if the temperature is minus 10 degree to 5 degrees centigrade, then one light salt truck needed. And if the temperature is greater than 5 degrees centigrade, then no action will be needed to overcome the situation. And it is also true for the accumulation per hour is between 2.6 to 5 centimeter. And as I explained in this section, this is also the same. And this is also true for ice. And if accumulation per hour is less than or equal to 3 millimeter, then no action will be needed. If 3.1 to 5 mm, one normal sand truck needed. If temperature is minus 10 degree to 5 degree centigrade, then one normal salted truck needed. If temperature is greater than minus 5 degree, then no action will be needed. And there is also the other value. If the accumulation per amount per hour is 5.1 to 15 mm and the temperature is less than minus 10 degree, then two heavy sand trucks needed, and this is the following. In the special situation, if accumulation amount is more than 15.1 mm, then the city will declare state of emergency and organize the army and other judicial support. Okay, and this is about the mixed type of weather situation, as I explained in the snow and ice part. And at the end of the program will analyze the data entered by user and show output which type and how many trucks should be needed to overcome the situation based on the input value by the user. And that's it. Now let's glance at the flow chart that we created for our non-technical users. This flow chart, the program will determine what is the weather type. If the weather type entered by the user is snow, then the program will follow these steps and generate input. And if user enters the weather type of ice, then our program will follow these steps and produce the outcome. And this is also true for the mixed weather, and this will follow these steps to generate the and this is also true for the mixed type of weather, and our program will follow these steps to produce the outcome. And here where you can get the exact output of which and how many trucks will be needed based on the input data. So this is the flow chart. Now let's move on to the solution. Why our solution is the best? Because this solution is the most efficient way to get the output using the input. The solution is free from errors and accounts for all the different weather conditions that could occur. And second one is the solution has also been tested and modified to make the whole process easily understandable to non-technical person. The third thing is that it will save your time by getting output by one touch of finger, and this solution is easy to understand and easy to input values. So this is my presentation. So